Lesson 10.3 on the volumes of pyramids and cones. Now, to find the volume of a pyramid or a cone, we use the formula 1/3 times the area of the base times the height. Now, you might be asking yourself, why 1/3? Most of the time when we're dealing with formulas, we're used to seeing 1/2 or maybe a quarter, but 1/3 seems like a very odd fraction to choose. I can't explain why using regular math. It's a very simple explanation if I use calculus, but that's a math that most of you are not familiar with yet. So at the moment, you're just going to have to accept that formula at face value. An example using this formula, say with a pyramid. Let's say we have this rectangular pyramid here. To find the volume of the pyramid, we just take 1/3 times the area of the base times the height. Well, since the base is a rectangle, we can merely just multiply the length times the width of the rectangle. 7 times 5 gets us 35 square inches. Now that we know the area of the base, we can use that back in our volume formula, taking 1/3 times the area of the base times the height. 1/3 times 35 times 8 gets us 280 thirds cubic inches. Now 280 thirds doesn't simplify to a nice whole number. Rather than rounding, we're going to keep it as an improper fraction. Another example of finding volumes of pyramids and cones, in this case, we'll use a cone for an example. And why not make it just an oblique cone? So just because it's slanted, remember, regardless of whether or not it's a right cone or an oblique cone, still we need to use the distance from the vertex to the base, in this case 24 centimeters, in our volume formula. So volume is 1/3 times the area of the base times the height. Since the base is a circle, we can just square the radius. 9 squared equals 81. Multiply that by pi, and we get an area of the base that's 81 pi square centimeters. Multiply that by the height of the cone, which is 24 centimeters. And we get 1/3 times 81 pi times 24 for a grand total of 648 pi cubic centimeters. Thus concludes today's lesson.